Welcome back to 8.4, graphing cube and square root functions. So on the first video I left off here and I said that I had forgotten about this pesky little negative sign here. So I think I'll just restart the problem, and I'm still talking about this x plus 1, and I still want it to be negative 8, negative 1, 0, 1, and 8. I still want those values there, so when I create my table, I'm thinking of x values that make negative 8. Well, there's only one that's going to make negative 8, and that value is still this negative 9. Okay, negative 9 plus this 1 right here is going to make negative 8. The cube root of negative 8 is negative 2. Negative 2, well, half of negative 2 is negative 1, but this negative 1 out front, or this negative sign out front, will make that then a positive 1 plus 3, which will make this 4. Now, after that, then I have to get this negative 1. Well, how am I supposed to get a negative 1? Well, I need a negative 2 for my x value. Negative 2 plus 1 would be negative 1. Cube root of negative 1 is negative 1. Half of negative 1, well, that's just a half, times that negative is going to be 1 half. 1 half plus 3 is 3 and 1 half. Moving on, how to get to 0? Well, I would need a negative 1. Negative 1 plus 1 is 0. Square root of 0 is 0. 0 times negative 1 half is 0. Plus 3 is 3. Then I have 1. How am I going to get a 1? Well, I need a 0. 0 plus 1 is 1. Cube root of 1 is 1. Times the negative 1 half is negative 1 half. Negative 1 half plus 3 is 2 and 1 half. And finally, how do I get an 8? Well, I would need a 7. 7 plus 1 is 8. Cube root of 8 is 2. Half of 2 is 1. Times that negative is negative 1. Plus 3 is 2. So now I have these points. Well, let's take this over here now. Let's graph it. So I have negative 9, positive 4, negative 2, 3 halves, 3 and a half, I should say, 1, 2, 3 and a half up here. Then I have negative 1, 3, 0, 2 and a half, and then 7, 2. And when I draw this one now, you might notice that it's not an S anymore, it's like a backwards S. This is turned around. Well, what made it turn around? Well, if you remember, I have this negative sign right here. It's turned around. How would I go from this value here to this middle? Well, I'd have to do what? I'd have to draw 1, 2, 3 up. So up 3 and right 1. So let's see. Oh, down here on the compare, that's what I just did. I went up 3 and I went right 1. Now that negative sign, well, it looks like it flipped the S around. It's almost like it reflected. That's known as a horizontal reflection. That's a horizontal reflection. Okay, and now if you also look at it, it looks like this thing's squeezed. It's a little tighter. It's way smaller. The distance from here to here is no longer 1, like it was down here. Instead, it's a half. So it's almost like it's been compressed. It's been squished. This is known as a vertical compression. Okay. Now, of course, I said all these S curves are going to have a domain of negative infinity to infinity. This is still an S curve. It's just been reflected. So it's still technically known as an S curve, even though it doesn't look like an S. And there we completed our next example. Brings me to the transformation equations. Transformations means how do these how are they transformed? Of course, it's definitely worth writing down each of these things. We've seen this stuff before. This A value right here, whatever number is stuck out front here, will either determine my horizontal reflection, and that is if A is less than 0. So if A is negative. If it's a negative value, it's going to reflect. Now the stretch, okay, the stretch here is the absolute value of A greater than 1? If it's greater than 1, it's known as a stretch. Is the absolute value of A less than 1? Well, if that's the case, then it's known as a shrink. Now the horizontal shift, of course, I will point out this horizontal shift has this negative sign attached to it. So it's opposite what you think. It's opposite what you think. Okay? And then the vertical shift, the K value over here, this is actually very straightforward. Okay? Exactly what you think. Okay? And that should be very, very easy. Very easy. Of course, I have the cube root ones down here. You can feel free to fill out that again. But we've already seen this stuff, and they actually all mean the exact same stuff. Okay? It means the exact same stuff. Okay? This is a blank slide. This is for when I do notes in class here, but now we're doing a video, so we're just going to skip right over this. Now this one here, it says compare the following functions to their parent functions. Okay? And it says indicate the transformations that took place. Basically what I need to do is I need to talk about every number. Every number needs to be talked about here. So let's start with this 2. This 2 is an A value. A values tell me if it shrinks or stretches. 2, the absolute value of 2 is greater than 1. Thus, this is known as a vertical stretch. Okay. Now, is A positive or negative? Well, A is positive here, so there's no horizontal reflection, so I don't even mention it. Next thing I look at is this 5. Now, the 5 is positive here, okay? But I actually know that in reality, this is supposed to be a negative sign. So that must mean that H is equal to negative 5. If it's negative 5 for the H, then that means that it moves left. And finally, we have this negative 3. That's the K value. If K is negative 3, well, then that means that it went down 3. And what I'm looking for when I look for the answers here from you guys is I want these items. Technically, I don't need the workbook. I just need that box. Look at the next one here. I have this negative sign out front. Well, it's negative 1. Okay, it's negative. A is negative. If A is negative, then I know that there's a horizontal reflection. That's right away. Okay, then I compare the absolute value, which is negative 1. Absolute value of 1, is it bigger or smaller than 1? Well, it's actually equal to it. If it's equal, then there's actually no stretch and no compression. Because there's none, we actually don't even state it. We don't state anything. Okay, so I've talked about that. Then I look over here, and I'm looking at my positive 7. This is outside the square root, so that must mean that it's a K value. If it's positive, then it must go up. Okay, this next guy here. So let's see. I got this negative sign right away. The negative sign, okay. Horizontal reflection. Next thing, okay, let's look at this. I see this 1/4. Is 1/4 bigger or smaller than 1? Well, it's smaller. Oh, well, if it's smaller, then that means that it's a vertical. It is key that you put vertical here. You cannot skip on this. Vertical compression. just moving right through it. Here, I got this 9 here. Now it's negative, it looks like, but that actually means that h is just a regular old 9. It's positive here, so that means that it moves to the right 9. Again, it's opposite of what it looks like in the equation. And finally, I have this positive 2. Well, that's k equals 2, which means that it goes up. If you really are confused on that stuff there, you should stop the video, go back, listen to it again, maybe make up a random problem and talk about it. Matching the following functions with their graphs. This one here, I actually don't want to go through these. Okay, I'll leave these for you. You can feel free to check these on the static notes. I have these filled out. Same thing with these ones here and these ones. Okay, now it says determining range, domain and range without graphing. This is key right here, without graphing. I'm not going to let you graph it. Okay? Basically what I need to do is I need to think about my horizontal and vertical shifts. I need to think about these horizontal and vertical shifts. Okay? They always start at 0, 0, usually, okay, for the square roots. These guys right here, these should be real easy for you to get, okay? And in fact, because they're already graphed, they should be super quick. Here I see that it starts down here on the x-axis, it starts at 3. Oh, well that's domain. That means it goes from 3 forever this way. Well, that's infinity. It doesn't include that, it includes that. Okay, what's the range? Well, the range, where does it start in the y? Well, the y, this is the point, it comes over here, it starts at 5. Okay, it starts at 5. This means that it goes up right over here. So it goes up forever, that's infinity. Don't include the infinity, include the 5. Feel free to do the one on the right. Okay, I'm not going to do that one now. Now we get into this without graphing them. Well, let's think about what this means. As far as moving, is this value here going to affect where it moves? No. Doesn't affect the starting point. Well, does this 1? Yeah, it moves it down 1. And this guy here, this -3, well, it's not actually negative, it's positive. That means it moves it right 3. It means my new starting spot's on the right. Okay, it's on the right, how far? Well, it's to the right all the way over to 3. Well, that means it must start at 3. And then it's going to continue. The range now, that's high to low. Well, how low does it go? Well, it's going to start down at -1, then it's going to go up. So that's at 1, and it goes up. Okay, just like that. Here, this 2 doesn't move. Doesn't move the graph. Are there any other moves? Well, there's no numbers. There's no numbers over here. So since there's no numbers, no moves. There's no moves. There's no moves, that means it's still at 0, 0. Oh, so the domain, it starts at 0, then it goes to the right. Oh, the range, it starts at 0, and then it goes up. And it's that simple. Any time that you do not have, okay, no h value, should look like this. No k value, should look like that. Looking down here at the bottom, I think these are going to be the last two on this video here. I'm just going to go through them decently fast. There is this negative sign. This thing means a horizontal reflection, which means I've flipped it over. No longer does it go up, it goes down now. So maybe I should start with the range on this one. This means I went up 2. Okay, so I go up to 2. That is actually how high it goes. Remember, this thing's going down. Oh, so it goes down forever, but it goes up to 2. That is the range. Domain now, that's not bad. Okay, that 6 means it goes right 6, so it starts at 6. It's still going to go to the right forever, and there I have my domain. Looking at this last one now, this +3 means left 3. Okay, left 3, well that's negative 3, it's going to go further to the right. That's the domain. This negative 8 means up 8. No negative. Stuck on this 4. Oh, okay, no negative. Oh, shoot, I was going so fast, I don't even know if I realized this. Okay, I don't even know if I realized that. This 3 is here. That means it's a cube. It's cubic. Cubic, we talked about this before. Cubic means, oh, that's always negative infinity to infinity. Negative infinity to infinity. Those are always the domain and the range. That made it a lot easier. Always check that cube. Don't do what I just did there, okay, even though I set you up for it. Make sure that you're checking to see if it's cubic. If it's cubic, it makes it easy. Negative infinity to infinity, negative infinity to infinity. This completes section 8.4. The two videos combined about 35 minutes. Okay, please make sure you understand this stuff. If you don't, come in and see me.